In example 2, we're going to determine if the mapping diagram is a function, and then we'll explain why or why not. We've got A, B, and C. C is hidden down here, but let's do A and B, and then we'll do C together. So an input of -1 has an output of 2, 0 has an output of 2, 1 has an output of -3, 2 has an output of -2, and 8 has an output of 3. Even though two different inputs have the same output, this is acceptable because each input has only one output. -1 has an output of 2, 0 has an output of 2. There's only one line being drawn from the input side to the output. So this is a function. And we'll write each input has only one output. Even though some of the outputs are the same, that's fine. This next one, -1, has an output of both 3 and 4. And right away that's a problem for us. 1 even has an output of 1 and 2. So this is totally not a function. And you just would need to have one of these for it to not be a function. So -1, two different outputs, 1, two different outputs. These guys don't matter, but they only have one output, it's 3. So this is not a function. And we could say there are some inputs, oops, that's supposed to be an N there, some inputs that have two outputs. Not cool for functions. Alright, let's move this up a little bit. And hopefully you can see C down there. And right now I'm seeing -2 is good, 3 is good, 4 is not good. 4 has an output, well, there's 3 different ones, and 10 has an output of 6. So this is not a function. An input of 4 has 3 different outputs. And it doesn't matter how many different outputs there are, as long as there's more than one, it will not be a function for an input. So if an input has 100 different outputs, not a function. If an input of 4 if this one had 2 different outputs, not a function. And 3, of course, is 2 or more.